Hi guys, we're going to do another video. I'm kind of skipping around. Number 2 on this is very similar to number 1, so I feel like, you shouldn't have trouble with number 2. Number 3 I might go back and do a video for. I haven't decided yet, but I did want to do number 4 because number 4 is very similar to problems in your homework, so I think it'll help you in terms of homework problems. So we are going to do number 4. A pharmaceutical company receives large shipments of aspirin tablets. The acceptance sampling plan is to randomly select and test 15 tablets, then accept the whole batch if there are only 2 or fewer that do not meet the required specifications, meaning 2 or fewer defects out of 15 tablets. If a particular shipment of thousands of tablets of aspirin actually has a 3% defect rate, what is the probability that this whole shipment will be accepted? So the whole shipment has a 3% rate of defects, but what we're trying to figure out is what's the probability that when we randomly select 15, that 2 or fewer will have defects. They're only going to inspect 15 tablets out of the shipment, and if 2 or fewer have defects, then they'll say, okay, the shipment's good. If more than 2 of them have defects, then they're going to toss the shipment. They're going to say it's not good. So to kind of help visualize that, I always look at our table. So in this case, we're talking about the number of defective tablets out of 15, out of a sample of 15 tablets. So this column, we're not going to fill out this whole table first of all, but this column goes all the way from 0 up to 15, okay? Meaning 0 meaning I tested 15 tablets and 0 of them had a defect, meaning they were all good. I tested 15 tablets and 1 of them had a defect, right? This is the number of tablets that had a defect. If we got to 15, that meant when we tested 15 tablets, all 15 were defective. That would actually be really bad. So it says accept the batch, meaning we'll let the batch go through to the public or wherever the shipping is going. Accept the batch if there are 2 or fewer that don't meet required specifications, meaning 2 or fewer have defects. So 2 or fewer. This group is the group where we accept the batch. Anything more than this, then we would not accept it. We would reject the batch. So anything from 3 down, we would reject. We would say, oh, there were too many defects, and this batch is no good. So what is the probability that we will accept the batch? So the probability we're looking for the blue ones here. We are looking for these 3 probabilities. So I don't need the whole table, I just need those 3. So in my calculator, there's 2 different ways I'm going to do this. This is part of why I picked this problem, was to show you that there's 2 different ways. Is this on? Hello. There we go. Okay. So we can do it one at a time, like we did before. So Binompdf, and that would be N is my total number of objects, so 15. P is my probability of success. In this case, the success is having a defect. So that defect rate is over here. This is my defect rate. So my probability of a defect is 0.03. And then I would do it for each of these individually. So I'm going to do it for 0. And write down this answer. Whoops. I'm going to round to 4 decimal places. It'll have to, the homework will tell you what to round to, but then I would do it again for 1 defect, the probability that there's only 1 tablet with a defect. And then do it again for 2 tablets with a defect. So this is fine. This is one way to do it. Kind of just doing them one at a time, getting what you need. 0, 6, 3, 6. Did I write that right? And then to answer the question, they want to know for 2 or fewer, you would add up these 3 probabilities. So adding up these 3 numbers. And again, these are rounded, so my answer will be slightly off because I rounded, but it should still be really close. And I'll round this to 3 decimal places, so 0.991. That's the probability. If there's a 3% defect rate in the whole shipment, that's the probability that our sample has 2 or fewer defects, meaning our sample is good enough that we accept the whole batch. So the shortcut that I wanted to show you is Binomcdf. What Binomcdf does, the P in PDF is for probability distribution function. CDF is for cumulative distribution function. Cumulative, think about like our cumulative frequency distributions from chapter 1. Cumulative means they're adding it all up as they go. So if I do the cumulative function, 15.03, and I'm going to do it for 2. If you do the cumulative function and you use x equals 2, the calculator is going to add up the probabilities up to the one that you input, up to 2. So it goes ahead and it adds it up for me. 9. So I told you ours was a little off. We got 9907. It's really 9906, but we were really close, right? So either way, it'd be 0.991. So the CDF is a good shortcut if you need it to add up multiple probabilities. It will add up all the probabilities up to the value that you input here. So from 0 up to that number. So that was just the shortcut that I wanted to show you. All of the 5.2 problems can be answered using Binompdf and Binomcdf. In addition, there are some binomial probability formulas for like mean and standard deviation, but those are in the PowerPoint and in the videos in my stat lab, so you need to watch those. But as far as the calculator is concerned, this is what you needed for 5.2, or these 2 functions. So let me know if you have any questions.